fructose 6-phosphate will proceed with the third step. The third step is quite similar with the first step. So fructose 6-phosphate will undergo phosphorylation. Again, can you recall back what is phosphorylation? This is a process of adding a phosphate group. So we get the phosphate group from the hydrolysis of ATP. So this ATP molecule, we get it from our own reservoir in cytoplasm. So we invest our own ATP, and we convert it into ADP, which is low energy molecule with the phosphate group. So this phosphate group, the second phosphate group that we have, attach it to the first carbon. Okay, so that's how you get from fructose 6-phosphate. When it is phosphorylated, you convert it into fructose 1,6-biphosphate. The reason why it is fructose 1, because the phosphate just newly added is attached to the first carbon, and the initial phosphate is attached to the 6th carbon, and the reason why you have bi over here, bi indicates you have 2 phosphate group attached to fructose. Therefore, you have fructose 1,6-biphosphate. Okay, the enzyme that catalyzes this phosphorylation of fructose 6-phosphate is called phosphofructokinase. By this time, you should know that you should be familiar with kinase, right? It's actually an enzyme to add phosphate group to a substrate. So in this case, the substrate is fructose 6-phosphate. Therefore, you're producing fructose 1,6-biphosphate. So now you have used 2 molecules of ATP from your own reservoir. We are only on our third step, so we have 2 steps to go in this energy investment parts of glycolysis. Okay. Now that you have fructose 1,6-biphosphate, let's proceed with the fourth step. So in the fourth step, before that, we need to know that fructose 1,6-biphosphate is highly unstable. Okay, this molecule is highly unstable, and due to its unstability, it's prone to be splitted, okay, to be cleaved into 2 molecules. So basically, we break it down into 2 fragments of 3 carbon molecules, and these 3 carbon molecules are dihydroxyacetone phosphate. Okay, so the first 3 carbon molecule is dihydroxyacetone phosphate, or DHAP, and the second molecule, the second 3 carbon molecule, is called glyceraldehyde 3-phosphate, or G3P. Okay, so this fructose 1,6-biphosphate is splitted or cleaved into 2 3 carbon molecules or fragments, which are dihydroxyacetone phosphate and G3P, glyceraldehyde 3-phosphate, and the enzyme that catalyzes this cleavage of fructose 1,6-biphosphate is called aldolase. And the reason why it's called aldolase is because this reaction of cleaving fructose 1,6-biphosphate is actually the reverse of aldol condensation. So condensation is when you're putting things together, so when you say in reverse, meaning that you break it down. Now that you have 2 molecules of 3 carbon molecules, which are DHAP and G3P, so let's move on to the 5th step. So the 5th step involves the isomerization of DHAP. So basically, DHAP undergo isomerization rearrangement, where it rearranges itself and converts itself to become its isomer, which is glyceraldehyde 3-phosphate. Okay, the enzyme that catalyzes the isomerization is called triose phosphate isomerase, and the reason it's called triose phosphate is because both DHAP and G3P are trioses. They are 3 carbon molecule sugar. Okay, so now that you change that DHAP to G3P, so now instead of having 1 G3P, after this conversion, you now have 2 molecules of G3P. So these 2 molecules of G3P will undergo the rest of the steps in glycolysis.